Okay. Testing 1, 2. Yep. If when at the end of the previous stream I was here, I didn't do anything behind my PC, but I did figure out what the problem is simply by thinking about it. It probably requires some ASCII art. We shall edit it. I'm gonna have to update scale. No, good. Significant, I guess. There comes the ASCII art. Let's draw a minimum. I did that before. No, of course I forgot how I did that. How did I do that? It's hard to grab for. Well, I'm gonna try. I'm pretty sure I have these two on one line with spaces between it. How often can that happen? Grab source for, I'm gonna choose X. Slash, actually that's a backslash. One or more spaces. Just like that. Ah, there, you see. Don't tell me that. Nah, I don't think this is it. Nope. And this is what I just added. How the hell is that possible? Maybe the other way around. Nope. That looks good, but I don't have the other one. Oh, how the hell can I not find that back? Of course it must be something with spaces in between. But also, I probably also drew arrows in between, so there's something else as well then. In between. Okay, I'm just gonna do anything but slash. It's not showing me. Yeah, I would almost think I deleted it. I had 4 parabolas drawn in ASCII art on a row. With those little arrows. I could search for the arrow, I guess. I don't even have my arrow stored. Oh, here. I think that arrow, for example, should occur there. Yeah, no. I don't know. I guess I deleted it. Right, spin lock. Definitely nothing to do with. Nothing to do. No, I'll have to reinvent it. I don't know. Oh, wait a minute. Yeah, I vaguely remember now that I did delete it. Yes, I deleted it. Ah, my memory is working. I have this flashback of the moment that I deleted it. Wow. Good old times. Yeah, even know the reason. Yeah, then I would have to start to dig into Git, old Git commits. Surely we can do this again. Let's try to go the other way. I also remember that was possible to do like that. And then maybe a point, because it was symmetrical, upside down, left and right. No, that's not bad. I think that's it, probably. Okay. And I want to draw a let's add an arrow here. That's the critical point. No. I think. Oh, now I have two L's. Let's make it a lowercase L. Hey, Louis. You have an unreadable name. I just see 4 square boxes. So how do you make a weighted average? How do you make an average? So an average would be, say the average between A and B is of course A plus B divided by 2. Yep, that's the average. But then you count A and B equally heavily. So weighted would mean that you have a weight, say W1 times A and W2 times B. And then you divide by W1 plus W2. So if you just pick W1 is 1 and W2 equals 1, then you get the previous formula. But if you pick anything else but W1 and W2 are equal, then you also get the same formula, the same result. And in this case I wanted to where we use W1 is A and W2 is B. So that then leads to where A is CP minus L. So no squared plus R minus CP squared divided by A plus B. I don't think I did any simplification there. Well, if I explain it like that, maybe I should use A and B here as well. So this is A, but not really, because this is the sample minus critical point, so it's a minus A actually. But it doesn't matter because so for the square it doesn't matter, and then on the other side I'm putting a minus sign in front of it to get the actual A again. Okay, let's define A as minus L. This was L. I want to get the actual A, which means that I have to swap these two. So it matches my documentation comments. And that means that now L is minus A. And then this we call B. And then, well, I just print A. And B. And then of course the sign doesn't change either. I mean, it's called the sign of A, so that is the sign of A. And the sign of B is the sign of B. But since A is minus L, this is now this is negated. So I should probably do unequal here. And then I set the result to one of them. Okay, I'll say I'm totally not following this anymore. But yeah, the sign of L was changed and the sign of L was changed. Yeah, so I just did it directly like that. You could drop the CP out here, but not here. So and since the formula is like that, maybe I should just replace here. Do things with Okay, yeah. It is so difficult to get signs correctly. You check it 20 times before you can be sure. So this image, you see that, I mean, with under this assumption, where we assume that the critical point is in between left and right, then left must be left of right, obviously, meaning L must be less than R. This is horizontally you have an axis that goes from left to right, like the normal x-axis. So L is less than CP and CP is less than R. I want to work with positive values for arbitrary reason. So we talk about CP, which is larger than L, CP minus L, and R minus CP, because then we get the distances which are positive. And we call those A and B. And then we want to have the weighted average of A and B, which works like some weight times A plus some weight times B divided by the sum of the weights. And then we set W1 to equal to A and W2 equal to B, because that way if A or B gets very small, then we just don't count it. That's the weighted thing about it. And while if there are, say, the distance between L and CP is equal to the distance between CP and R, meaning A equals B, then we get the result should be A plus B divided by 2 or something like that. I don't see it. Yeah, I guess if A equals B, then this is 2A squared, and this is 2A. So the 2 drops out and 1A drops out, and then the result is just equal to A, or equal to B, because they are the same. So if the distance is the same, then you just get the distance, either to that one or that one. And if the distance is 0, then you also get the distance to the larger one, which was the objective. But all this only holds if CP is in the middle. Nevertheless, I want to check if I'm so not getting this part. Oh, now I'm getting it. Yeah, so this is wrong then. So if the sine of A equals the sine of B, that's kind of... Try to understand why I'm not just having always a positive sign then, if they are equal. I mean, there's just three possibilities. Either L and R are both on the left side, in which case A is positive because L is on the left side of CP. And B is negative because R is on the wrong side. And then you have the possibility that both are on this side, and then B is positive and L is negative. And the only other possibility, because L must be less than R, is that L is on the left side and R on the right side, which means that both A and B are positive. So it's not possible that A and B are both negative. So why would it be checking it like that? So the unequal then kind of means like they're on the same side. Anyways, so that still makes sense, I guess. No, because we asked if debug output would help, but it won't help here because I'm not looking for a bug. I already know. I mean, if you want to understand why the code doesn't work, so you're looking for a bug, then debug output helps. But now I'm just writing code out of nowhere. So I need to understand what I want rather than what the code is doing. I just swapped the meaning of, so I replaced L and R with A and B, and I swapped the meaning of the sign of A. And that's why I'm going meticulously over it again, but there's not really a bug. It's just I want to make sure that I didn't introduce a bug relative to the previous code. Yeah, and then, like I said, so it's rather L must be left of R. It's more logical. I'll explain it in full. Therefore, if L and R are on opposite sides of CP, then both A and B must be positive. It's almost nonsensical to test it because it's sort of like, well, trivial. But, well, why not? It's kind of a comment or an explanation in itself. You know, you can see here that the sign of A and B are both positive. And if then you look at this, you understand that the result is going to be positive. Because A and B are both positive, so this is positive. This is obviously positive, because it's just sum of two squares. Therefore, the result is positive. Moreover, you will never divide by 0. Well, you would if they're both 0 and you consider that to have a sign of +1, but But both are 0, that's kind of stupid. So it means that both the left and the right sample are exactly on top of the critical point. It should never happen, because I wouldn't even add those samples. I'm only adding samples that are significantly different. So I can't have two that are at the same spot. Okay, that all being said, now we have to deal with the fact, now we have to deal with the case where L and R are on the same side. And this is wrong. Because what the problem, the thing that I did run into is that what I had is, well, I can make that drawing here, I guess. So now we're going to assume that both are on the same side, but L must be left of R. So I'm going to move L a lot further to this side. Let's say put that one here. This is now R. Rightmost sample. And this becomes the leftmost sample. This is gone. And you have an L here. So they're on the same side. And so the previous code was then just picking the one that was the furthest away, I think. So he would get L minus CP. That is ridiculous if L and R are close to each other and CP is very far away. So that's what happened. We had L and R were in the range of 10 to 20. And CP was at, I don't know, 10 to the power 20 or something. Very far away, of 10 to the power 13, but billions and billions, hundreds of billions, thousands of billions, 10,000s of billions. What comes after billion? Away. So then saying that the scale is at a trillion, a billion, is ridiculous. And I think that it would be much better to have the scale being the distance between L and R. But for some reason I had the feeling that using an absolute value of A here times A plus the absolute value of B times B would do something. If they're both positive, like in this case, it doesn't matter, they're both positive. But if you do that in all cases, and one of them is negative, then you suddenly get subtraction between the two squares. So then you have A square minus B squared divided by A plus B is A minus B. And if you then do that the right way, then you'd get A minus B or B minus A such that the result is positive. So I think that is actually a logical solution. But yeah, I'm not sure if it's, well, maybe it is cheaper to get the absolute value of a double than having a sign compare, especially if I don't need the signs anymore at all. So that's where I was heading actually. So let's say in this case B is negative, therefore I want to end up with, but B is, wait a minute, distance, the absolute value of B is less than the absolute value of L minus CP, sorry, CP minus L, so A, help. Okay, so in this case I want to get A plus B, I think, because B is negative. I want to get this distance. So that would be this distance from CP to L minus this distance, which is a plus B. Because of the symmetry of that, it's also going to work on the other side. Yeah. Yeah. Get from here to from this formula to that formula. Really. Maybe we should just start with the answer and then show that the result is correct. So in this case, only A is negative and B is not. So this then would be minus, the absolute value of A is equal to minus A. And B is just B. That is B plus A, damn it. Well, in terms of absolute value. It's not what I want. Okay, so this is nonsense. And I'll just need to do this check here. And then I guess I can just set the results to A plus B. Yeah, it's kind of makes sense. If this should be the result, then the only way to get this to work would be to change this thing into A plus B squared. And that means that I have to add a 2 times A plus B factor in here. Nah, doesn't seem to make much sense. And this works for both being left and right, because the negative value is always the one that is closer to CP. So the absolute value of the negative one is smaller than the absolute value of the other one, which is positive. So this will always be positive. To add an assert. Please watch this. No, I'm gonna see if that fixes. Okay, so again, this is a parabola about till here, and then we get a kink, and then we switch to a different parabola. We start here, the tangent line is like that, and we decide to go downhill. Then we go here, come here. Now we have 2 points through which we can fit a cubic. And the cubic looks very much like this parabola, at least in this area. It does also, it has a minimum here, of course, because the parabola has a minimum. So the cubic also has a maximum, but that maximum is like far away. I don't know if it is on the left side or the right side. Nevertheless, so the algorithm deals with just one of the critical points of the cubic. And well, the one that we're interested in, which is obviously the minimum. So we now jump to the minimum of this cubic, which is here. And the resulting cubic still matches 0, the 0 point. I mean, I just started my samples. I started to label my samples from 0. So this one is still, could be a part of this cubic here. So the scale now is from the minimum of the local minimum of the cubic that we did fit till the point that is the furthest away from it, which is here. But that is then the rightmost point, and the leftmost point is number 2. There is no other sample on the left of this, it's the leftmost point. And these two are on the same side as the critical point, as you can see. Therefore, the now calculated scale value should be the distance between 0 and 2. Which, I don't know, is what? Can I read that from here? That's 12, I think. So it's something like 12 plus, what is this distance? 3, 15-ish. Yep, 15 and a half. So yeah, one is negative, and then we just add those two and you get 15 and a half. So that works. And then we jump to the local minimum again of this cubic. And then we are then using 2 and 3, we fit now a cubic that matches this parabola on the left side. And therefore 0 and 1 no longer fit. So the scale is now adjusted to only to have a 2 as being the rightmost sample that fits the approximation. And in this case, I don't know if it is on the left or the right side. It doesn't really matter. I mean, point number 3 could be tiny little bit on the left or the right of the CP, but whatever. In one case, we would have a weight of almost 0 for this one, and we would just return this distance. And if it's on the same side, we would return the difference between the two, which is also the distance. So either way, it's going to return, no, I said it was 3, so something like 4.5. No, 4. Okay. Apparently it's negative, so it's slightly on the same side still, 0.3. So we get the difference between these two, and this is minus 4.25, I guess. The distance is minus 4.25. No, I believe it. So what would happen now? Now we found the minimum, so we're going to fit the fourth degree polynomial, which does not have zeros. And therefore you just keep going in the same direction. So it goes to 5. And that repeats, because it's, again, keep going. It already says that it is, it already says here at the bottom what the next point is. So keep going, and it's going to minus 16, so somewhere here. Oops. And then still keep going, still no other. Well, we're looking for a maximum now, and the fit doesn't have a maximum. Well, it does, but we are ignoring it because it looks too much like a parabola to assume that maximum of this cubic has any meaning. So we go there, and then we go there. And now we have already too much energy used. Doesn't look like it, but this is the previous point. So the next step is, I don't know. Yeah, whatever. I mean, it's almost there, so I'm okay with that. It said that we don't want to go further. So now it jumps back to the best minimum, which is here, of course. Plus a little bit. Restores the scale. And then jumps the scale distance. Well, we were never left this local extreme here, so I don't know what the scale was, but apparently the scale was this. It's not drawing the scale. It's kind of stupid. Why not? Yeah. Yeah, apart from that, one step further, I mean, I think that now we want to start over. The scale is reset now. Let me have a look what happened here. 0.9. Pretty confused here. Just returning this, but the indentation doesn't fit this indentation. Yeah, maybe, okay, but this is printed by handle abort H direction, whose value is always returned then. So maybe just this is what was returned, but we're still inside the one scope extra. Here's where the value came from. Best minimum opposite direction. So the opposite direction means then just that we did add something. That was before the skill reset. It's like the last scale was 13. I think that value was still added here. Was it not? So we jump to the critical area or critical point of minus 7.75. Oops. And then if I add to minus 7.75 the 13.1788, you get 5.4288. Yeah. So it used this value, which came from the points at minus 23 and minus 3.5. So this one and this one. Okay, well, yeah. So this fit fits those 2 points. I mean, it fits 2 and 3 and 4 and 5 and 6 and 7. 8 was rejected because it used too much energy. And 1 and 0, which is already removed from the history, were removed because they deviate too much. Removed from the scale, basically. Yeah, and then so this amount of the weird thing here is though that you see that this is like infinitely far matching, and the matching stops here about because then a little bit further because then we move to a different problem. So if the energy was way larger, then we would have gone way further in this direction, increasing the scale. I mean, if the energy was just a little bit larger, then we would have included 8 already. Step is every time doubled. So then we would have went all the way here. If the energy was very large, you would have made a very large step to the right, which seems a bit incorrect. But it doesn't matter. I mean, it should be able to recover from that. In this particular case, the step is not that bad at all, I think. I mean, it's much better to make this step than to make a tiny little step, or a step that doesn't even go beyond the 2. You kind of want to skip all the points that you already checked, so this way we definitely stepped over the 2. We got new information because we are now having a little bit of deviation. This step is kind of perfect, I think. Okay, then now the next point was well, I would have expected a 10 to appear. I had a 9, I press a space and no 10. What happened? Oh, it's here. Sorry, it is here. 10. This was 10. So it drops off the graph at the top. It's a little, somewhere there. And the thing is that now this is the cubic fit, of course, because just using 9 and 10, we would just fit this parabola. Just starting from 0, it's another parabola. Till that fits correctly, and then we have a maximum at 10 to the power 13 or something like that, super far. So before, the scale was changed to 10 to the power 13, because we're just averaging that distance from 9 to the critical point and from 10 to the critical point. And now I changed my code such that now we should get a scale that is equal to the distance between 9 and 10. And that's a real bug fix, because after this, well, everything went wrong. The scale was super big. We just kept going like before, and we made a step of 10 to the power 13 or something like that. Yeah, perfect. Well, perfect, except that floating point round-off errors are rearing their head. I am having still not 13, but 11 then, okay, or 12. So A and B are both around 10 absolute values for A and B are around 10 to the power 12. And then we take the difference of that, and then we still get 13. But that's probably not what I should do. So, considering that the critical point could be very, very, very far away, I should not add A and B. I think I should just subtract the values, these values directly, these two. See if the floating point round-off is already visible. What I really wanted to have is 18.6076 minus 5.42878, 13.1788. Damn it. It's still as accurate as it is printed. But yeah, I mean, so instead of doing A plus B, I'm doing you gotta wonder if the compiler already did it. I mean, the compiler sees that A is difference between these two. Well, yeah, nah, probably not. Anyway, A is this and B is that, so A plus B is B plus A is this minus that. No, and then the next, it just keeps going and then it goes over the energy again. And then then it stops, so okay. Found global minimum at minus 7.75. This one works. Double free detected. To fix that, I hate it, but we have to fix every error. Never ignore any error. Yeah, I had a feeling it would be this. But why? Why would it be double freed? How that would happen if we make a copy. Don't tell me you make a copy of DE. Well, I for sure don't have any support for that. Let's add it. Well, let's begin with not allowing to make copies, and then see where the hell I want to am trying to make a copy, because that in itself feels strange, doesn't it? The vector is part of scale. Well, maybe I want to make a copy of scale. I don't know. Could be. So the vector copy constructor. Delete. No, you're not allowed to do that. Call to implicitly deleted copy constructor of approximation. I'm making a copy of approximation, which is a scale as a member, and then the scale has the double-ended vector as a member. Next step is getting rid of the parabola. We're slowly moving from a parabola to cubic. Anyway, we're making a copy of the approximation, and the main reason is that I want to have a copy of the cubic. But this thing also has a scale. A measure of over what interval? Yeah. Should not really make a copy of scale, I think. Could add a shared pointer or even a unique pointer maybe. Nah, shared pointer I guess. Could you add a shared pointer around this thing? I don't know. I think that maybe the copy should be a move because I don't think I would use the original anymore after copying it. Feels like the right thing. Yeah. Now, of course, you can copy a vector. So I can't really disallow copying the vector, but I can disallow copying the scale. But yeah, I'll have to fix the DE vector first, I think. To fix this, I have to add both a copy and a move constructor. By the looks of it, they have to be const expressions. Not even going to look it up again. Everything is a copy const expression these days. Can I inline that? Yeah, well, the move on can be inlined, I think. Yeah. Maybe I should implement a swap. Nah. I don't know. So we start like a copy constructor, just copy everything. Nah, I'm gonna do it the dirty way. Let's do it not in line though. Let's do the line. It's almost nothing, but it is something, right? Let the compiler decide it, I suppose. Destination source count. Destination this. Source original count. Size of this. And then the original, which is being moved, must be not used anymore, but it must be destructible without side effects. So because we're not allowed to use it anymore, I could just only set the buffer to 0, so that this is so that it is destructible without a side effect. But then it's really corrupt. But hey, that's so good enough. So I'm just leaving the size as it is. So if you still access it after this, then you will crash. It's not allowed anyway. It's very original, of course. And then the copy constructor. Can do that outside here. So you need to make a new allocation. with, yeah, I would like to make it exactly the same. So I have my capacity, which is bytes to allocate divided by size of t. Theoretically, we would like to just assign the result of this function. Not sure what happens if I pass capacity to this because of the +1 here. I think it should work, right? Yeah. Whatever this returns, it has a minimum capacity that is 1 larger than what is passed. But then we add subtract size of t again, which means that this becomes 1 less than what it would have been without doing that. So confusing. The problem is that the initial time that you call this capacity can end up larger than min capacity. But things will still work out as long as malloc size returns the same value, which it only will, if you ask me, if you pass the same value to it. Which means I have to reproduce well, you don't. I think that if malloc size is such that it returns something, and then if you call it again with that same value, it should return the same value. Or not. Yeah, because it might return something that is larger, but only because you would get that anyway. But if you allocate this much, then it's anything. That is what we want. Nope, I can't wrap my head around it anymore. It's not documented good enough. I would say that if you feed this back into malloc size, it should return the same value. But then I'm confused with the existence of max malloc size. Yeah. So the reasoning is, I suppose you have a malloc that allocates always at least 4 kilobytes. It does not have any overhead, to make it simple. Sorry. So if you call malloc with 4K, then it will allocate a block of 4K and not more. And that's returned, and then you have your 4K. So now we call malloc size with 1K, then it will return 4K, because it knows that if you allocate 1K, you get 4K anyway under the hood. So you would throw away 3K. You would not use 3K because you didn't know that you actually have an allocation of 4K. Suppose we pass then, so we get 4K. But then if you say, how much memory will I get if I allocate 4K? Well, if I want to have at least 4K, it's still going to return 4K. And now I suppose it does have overhead. So say it always allocates 4K, but it needs internally 1K. A very efficient malloc. So, and then if you ask for 1k, it's going to return 3k, because if you ask for 3k, then it will still allocate 4k, because it has 1 kilobyte overhead. And then if you ask for 3k, I mean, you get 3k. So if you try to allocate that and it has 1k overhead, it just fits exactly. And if I call malloc size with 3k, it's going to do the same thing, and then think, well, okay, that will work. You can just allocate 3k. So yeah. I think it's pretty much a given, right? That whatever is returned, if you put that in it again, then you get the same value. So I want this to become equal to what it was the previous time, assuming that this was already the maximum. Yeah, so if I pass the capacity that was returned here or set to this function, then that capacity was, I mean, the number of bytes to allocate divided by size of t, if is, because of a round off, it could be rounded down, is at most bytes to allocate it. Bytes to allocate it? Bytes to allocate. So this times that is at most this, or maybe less. Maybe 1 less. But it could be the same size. Less is not bad. And then I can add size of t to that. And then we have the real return value of malloc size. And that is what I want to pass. Therefore, well, this already adds size of. So what I really want is that min capacity times size of t is equal or less than this bytes to allocate, which is just capacity times size of t, and the time size I already have. So if min capacity equals capacity, then it just works. I think it's either mind-boggling or I'm really getting stupid, but I'm still not sure. I think it works. Should we allocate buffer capacity? Boo-boo. Okay, and then we still have to copy everything. That's original, of course. Yeah, that would be the copy constructor. I'm so not going to test it. Right, so we fixed without testing the D vector. And then we go to the scale. And I just don't think it's a good idea to copy the scale. Nah. Copy scale. Why would I want to copy the scale? Yeah, I even disallow assignment. Why the hell would I disallow assignment if I want to? And then still allow copying. I don't know. Okay, so now you should get the same error, but now it's just because scale is not copyable. So approximation can still not be copied because scale has a deleted copy constructor. Good. Now what happens if I add a move constructor to scale? I don't know where to add it. Yeah. Right. Now most is just copying because it is built-in types. They can't be moved, or they don't have a move constructor. Might as well copy them. I don't think they're the same with the cubic, right? It's just an array actually. So this thing doesn't have a move constructor either, but under the hood, I think it's compiler generated then. So it should have a move constructor, which then uses the move constructor of the array, which is probably just equal to the copy constructor. So it doesn't really matter. Might as well pretend that we have a move constructor. But then this is important. Here we just send the move costs the thing to our value reference, and therefore we call the correct constructor, namely the move constructor, which I just added. So now it should compile again, provided I'm using the move constructor on scale, but I'm not, so I think it's still not compiling. Yeah, so the reason is that now we're trying to copy approximation, which is as a member scale, and scale does not have a copy constructor, but scale does have a move constructor. So what I can do is move construct this approximation. Then of course after that approximation is not usable anymore. So it must also be known. Standard move. So now, but because of this cost, we call the move constructor of approximation, and which I added, right? I'm highly confused now. I thought I added it. Where is it? I don't find this error particularly readable. I mean, it says that it can't construct something. So the first thing I would like to know is then what can it not construct? to just say what the args is, I think. No, actually, I have no idea. Anyway, in instantiation of function template specialization, standard allocator traits, standard allocator, standard list node, gradient descent, local extreme, construct, gradient descent, local extreme. So I'm gonna assume that it's about the construction of a local extreme. Requested here. Well, that's still not in my code. This also not. In instantiation of function template specialization, standard list, gradient descent, local extreme, create node. I have a standard list of local extremes, I guess. And the standard list has a problem with creating a local extreme. This is my code. In instantiation of function template specialization, standard list, gradient descent, local extreme, and place const, I hate it, and place gradient descent sample const reference approximation reference double requested here. So because it's in place, this means that I'm trying to construct a local extreme with this as arguments. Candidate template ignored, substitution failure. No matching constructor for initialization of gradient descent local extreme. So yeah, extremely unclear. But everything points to another file except this one. That is my file, and the rest is, I don't know, it's the standard library. So we'll have to do with just the line number, I guess, and the knowledge that something is wrong with the local extreme construction. So extremes is a standard list of local extreme, that's correct. And we do an in place. And then we pass these things. History code, approximation, and an energy. Well, there has to be the approximation because that's the only thing I changed. So you're going to, yeah, the type didn't change. Oh, maybe this is using a copy constructor. Oh, right. Yeah, no, of course. Finally, I'm getting it. I feel really stupid here. Yeah, that is problematic. I mean, to make it compile again, we have to move approximations now instead of copying them. So we'd have to add a standard move here. But that means that afterwards I'm not anymore allowed to do anything with the approximation that the approximation pointer is pointing to. I'm not even sure what it is pointing to, but probably to the thing on the stack. So I'm moving something that is on the stack. And then I cannot use that anymore, but I will in the end. In the end, I'm going to use it again. So really, I just want to make a copy here. I don't want to move it. On the other hand, I'm not really going to use it anymore. We're going to call reset on it. So you could say, I'm moving it, and then normally you must make sure that a moved object is destructible. But you can also say, well, after this it's destructible, but you are also allowed to call reset on it. And if I make sure that that is the case, then I can still call reset on it. And I guess that's what I should do then. So, but it requires debugging, I think. So what you're going to do is I'm just going to move it because, yeah, can only move stuff. And then that means that we're moving an approximation. So now we call the move constructor of this approximation, which I couldn't find anymore while I was sure that I added it. Maybe I didn't add it. It was just generated now automatically because scale only has a move constructor. Did add it to scale. Yeah, this was the last one that I added. Okay, meaning then that we have to add a move constructor approximation explicitly. Yeah, this whole thing doesn't have any constructors yet, so the default constructor and then the copy constructor. We cannot have a copy constructor because scale has no copy constructor. So don't really have to delete it. It will be automatically deleted anyway. I can, however, add a custom move constructor. Let's have another look at scale. Yeah, so this one deletes a copy constructor already. So this one won't have one. So before this was generated automatically by the compiler, exactly as what I'm now going to do. Very boring. But then I'm going to make one little change to it. Not sure if that needs to, probably needs 2 braces. No, let's just move again here. Original. Okay. So afterwards, we should not use this approximation anymore. Rather, actually, we should not use the scale of this approximation anymore because the rest was just copied. So I'm allowed to call reset because I'm allowed to call reset on scale, and the rest is not interesting. Really? I'm not allowed to call this anymore. After it's being moved. I'm not theoretically not even allowed to print the scale anymore. I guess that won't hurt. So what I'm going to do is add a debug boolean that says moved. So after reset, after the scale is reset, again only the scale is interesting for this thing. After it's call to scale reset, we are allowed to use it again, which on just resetting moved, the boolean moved, which actually is debug code, and I missed the key, debug. Here I can add not moved. Okay, so check the scale. After moving the scale, the problem is that that moves the E vector, which I left in a state that is completely corrupted, deliberately timid, so that you can only destruct it. So then we have a problem. We want to recover from that because I really have to override it then with a newly constructed something in the reset. But yeah. Actually, I'm calling clear on it here. Maybe that's allowable then. Even to recover from having being moved. Yeah, let's try that. To the move factor of the E sets above to null, so that we can destruct it. And then you're not allowed to do anything else, but now I want that it is allowable to call clear. And that means that it must return really to the original state as being just default constructed, which is a null pointer. And apparently the rest must be null. And what I'm doing is I'm setting the 0 index to capacity divided by 2, and I'm leaving capacity alone. So that's no longer correct. And I can fix it by setting the capacity to 0 also. Yes, so now if you move it away, then the buffer is set to, oh, that must be original, of course. The buffer of original that was being moved is set to null pointer, so you can just destruct it. And I set the capacity to 0, so that if you call clear, then the size becomes 0, and the 0 index becomes 0, and capacity was still 0. And now we are exactly in the same state as default construction. Yeah, I think that works. So I decompiled. Now we're using the move constructors. And then the only question is if we're going to assert somewhere or crash here. Let's run some tests. Fixed. So you see, I could ignore it, like I close the window and I get a final crash, but it was terminating the application anyway. So I could have thought, yeah, who cares, you know, like a crash at the moment you want to terminate the application, who cares? But it turned out to be something pretty involved. Adding move constructors and God knows all what. So it's always important to take any error seriously and fix them. So this one now works. Let's do all the tests in gradient descent old. The thing is pointing to old still. Yeah, I don't have a random anymore, right? Fix me here. I think this is a test that I'm testing now. I want to test this one. That's probably going to assert because it needs code that I didn't implement yet. But okay, let's go downhill. It's a really small step. But then the next one is already almost right. Now it should be exactly right. The next should be fitting a 4th degree polynomial. And this. And then we should jump to this one because that's lower than that one, then making us go in the right direction. And it does. And I think that now we did reset. I'm not seeing a tangent line here though. Not sure why. Something goes wrong here. It's returning 200. It's like way too far to one side. Why does that happen? To the 15 here, that is that last point. 5. This is turn the directions to the right here. Next extreme is a maximum, so we're trying to find this maximum here. Now the 15 is added to the history. Kinetic energy is sensible. And update local extreme scale. It's adding 5 to the scale of the minimum, I suppose. Scale update minimum. Ignoring the new symbol. Because it deviates too much, and you can see that. This is the approximation, the purple thing. 0.5 is absolutely nothing. It's not on this approximation, so it's not part of it. So the scale is not updated. That is, it remains 0.4 concluded from something on top of the critical point to something that is that distance away from the critical point. I guess that this B that's the right edge, so that must be the 8.12, which is, I don't know, one of these, not this one anyway. Even this one would be far away, too far away. It's not mentioned. Yeah, I think that, left here. This is the scale, so it's very small. So I don't know why this is not counted. I think it's pretty close. You can state it here. The scale has samples at 7.6, 7.73, 8.12, 11. So it did have this point. So it must have rejected this one as well then. 11 and 12, yeah, that's where we did begin with. But left edge is 0 and the right edge 2. So that's the index into this array. So apparently it's too far away. Yeah. Okay, we can try to find that back. Yeah, ignoring sample because the cubic at that point is minus. See that? This is the point, and the cubic is minus 0.01. Okay, so this is 0.5, so this is 0.1. Wait a minute. Yeah, this is 0.1 is the value where it is. Now the cubic is at 0. And yeah, that's true. Cubic is way closer to 0. 0.01. And that distance, sorry, the height of the cubic minus 0.1, so that is the vertical distance. Absolute value of that is 0.1, so the deviation here is 0.1. Is larger than 1/10 of the distance between that point and I guess the critical point, this distance. Okay, so it's almost this distance, which is more than 10% of the distance to the critical point. So it was allegedly ignored. Anyway, we're still not at why the hell it returns 200 here. Okay, so the cubic that is being fit here has a minimum at 7.68. That would be there, and it looks a lot like a parabola, but it is a cubic, so in the end it's going down again one side, and apparently it's going down at 200. So it is going up, but it eventually will reach a maximum here around 200. A lot to the right and a lot up. Because here it says the maximum. Maximum is at 200. This is based on 2 points almost on top of the critical point. Handle approximation 15.7. Returning approximation, find extreme. We are looking for a maximum. Returning right because this is where the required extreme is. Yes, it is, but it is a ridiculous extreme. Got the gems there anyway. Okay, well, yeah, oh, okay, well, if you ignore this point, and then that's what you get. We have only 2 points here, super close together, so it has no clue about the progress of this thing around this point here. Would it have been better to have another sample here? Or hell, to even use this point itself, which I already got. So that seems really wrong, doesn't it? Not fitting a cubic through 0.5? Oh, that's weird. We have 5. So why is the approximation not adjusted for that one? I think it's just an old approximation. This is the approximation for these 2 points. We are now there. And it's still jumping to a maximum based on the previous approximation. Oh, now I'm having the feeling that something is going wrong still with what I just changed. Yeah, this is not good. The approximation should have been updated, I think. It's tough to say what's going on. Why that is not the case. But clearly it's now jumping to an pretty ridiculous maximum of this one. Way too far to that side. Well, I think it should have should have used 5 for a new approximation, and then we would have jumped to the correct maximum. This is super close already. Then the question is, why was 0.5 not included in the approximation? 0.5 is at 15, so this one. And then we get the height and the derivative only at this point, so only after this point you can include it. It's not using it. Wahaha. It is not using it. Yeah, I think I get it. So it's rejecting the new sample, what it's doing is it's still working with the approximation that belongs to the minimum, the last found local extreme. And it does not want to update approximations of that, because that approximation belongs to one that of a minimum that we already found. Therefore, it just calls update local extreme scale, which only updates the scale and not changes the approximation itself. But then it discovers that this new point doesn't fit that approximation anymore, which happens here. And it returns away from critical point, which is true, but it should not. It should not have returned this. It should have returned disconnected. And then the disconnected should have caused a reset, and then we would start over with a new approximation based on 5. And even that I don't like, I must say. Yeah, okay. So it's definitely not finished then, scale, because it's never even returning it. Disconnected. That is totally missing. So instead of we return away from critical points, but if the scale wasn't increased, I should have returned that, which I didn't do. think this should be moved up. I'll explain what I'm thinking. So I'm only interested, this is the update of the scale, and well, for this particular case we just found a minimum, so the local extreme should be set. So knowing that local extreme is true, this is just printing the arguments. Well, I didn't check it, but I think it should have been here. So if the local extreme is true, then this will be false. Otherwise, you would assert this is, yeah, therefore just skipped. This is skipped. This is just an assert. The cubic didn't change then. The approximation. And here also you cannot have just two samples in the case of a local extreme. You can also see that assertion. So because local extreme is known to be true, then we know that we won't go in here. Again, just debug code. So now I'm here. And now it's going to see if the new sample fits that cubic or not. No, it's inserting it. Sorry, it's inserting the new value in samples. You just keep track of all of them. You see that the local extreme is already found, and really we don't want to add a new sample in between already existing samples. That is just silly. Should make a jump so far that it's has to be added on the edge. So either completely at the front or the back, going left or right. And now we're here, so it means that, so, okay, we're going to do this. So we're not going to do this. And then we are at the end. And then I'm returning away from CP, because it is a local extreme. Yes. So what's it doing in this part? If it is a local extreme, then we test if the sample fits. If it fits, we do this, and if it does not fit, then I just print that fact. But I should return here disconnected. Now the comment says that I should return disconnected if the scale is not increased. But since it is on the edge, I think it's not really true. I think it should only return disconnected when it's no longer fitting. So that would be here. But stuff still has to be done. Some stuff anyway. At the end of this scope, So it just continues here. The only stuff that needs to be done is calculating the value, but that didn't change either then. So I think, yeah, we can just immediately return. I mean, it just literally did not change if you don't recalculate it. But yeah, it can't have changed because we just ignored the new sample, so all the remaining samples are still the same. The approximation itself was not updated, so nothing changed, so the value cannot change. So I might as well immediately return at this point here. That was missing then. Well, this is always true. And then I just return disconnected. But am I doing something with it? Because this function was update, yeah, just skill update. That doesn't help. Updates. One of these two. It was not update, it was this call, the update local extreme scale. So it's this one. So result is equal now to disconnected. That then is returned from update local extreme scale. Just called here. Yeah, and we're doing something, and we will assert because this code was apparently not written yet. But okay, I'm gonna see that. Go to the minimum and then we assert on the false. Very good. Yep, so it says disconnected. Return disconnected. Okay, and then it's the question, what to do? I don't know. I think I'm going to take a break. I have to eat dinner. And I can think about it, this problem, what to do without staring to my screen. This it's a good moment to lose another game of chess before I go, because I just can't get up. It looks interesting though. I have to using Stockfish to automatically find tactic puzzles. Who is to move here? White, I guess. White can take a rook. No. Can take the knight. That looks like one deep or not. Take the knight, go there, push the pawn, sacrifice, instant check. Okay, it's maybe not that easy. Oh, well, no, you can take it. And here. Yeah, I'm thinking about taking here. Then he takes there. And you take here, check. Then he has to take probably. You take there. Then you lose that one. You win 5 points or something. No, you will lose 2 rooks. Bishop takes b3, penalty, it does win. Yeah, not very scientific. Some guy doing gut feeling stuff, like myself, I guess. Well, bad move. Queen check. What am I gonna do? I cannot do this because he just takes there. And he's gonna take there anyway. So, damn it. Yeah. No, this one is attacked. So, maybe I can put my knight here. Oh, that's nasty. I wanted to trap the queen. But Yeah, not good, man. Why is he not good at all? I'm going to be jacked. I'll just have to move my king afterwards. So I have to move my queen. And then nothing. Let's try this. Well, no. If I do that, the knight comes here as well. I think I just have to exchange queens. Okay, I want a knight where my rook is, basically. That's not gonna happen. Maybe it is, though. Yeah, I got my knight where I wanted. Why did I give a knight away? Oh no, I didn't. The rook is defending this board. Yeah, I'm threatening mate. So he's losing the bishop, right? Can't do anything about that. I can give check now. Give check and then solve the mate threat. Oh, it doesn't see it. See, you can't even talk to those guys anymore because they immediately leave, which is sometimes annoying. You just give check and then I do something and then, I don't know, king to the side, or is it not good enough? Of course that's good enough. Give check then. This doesn't look as bad as it is, does it? Oh, it is bad. Okay, check, and then I go away, and then king to the side, and then I'm still winning. Oh, I'm winning the bishop like that then. Yep. It's okay, so the bishop was always lost. Interesting. So from which point on is this a tactic? I've been +5 for a long time. From this point on it isn't check, but not really, because you can also play b3 and then still have a very good position. Like the problem with puzzles is that they demand that only one move is good. Well, this is kind of an intermediate move. You attack the rook. Yeah, the rook has to go somewhere, and then after that, this is still good. Rook g4, same thing. Just a tempo on the bishop. Bishop goes somewhere. Oh no, not this. Okay, we still have to play that one. Go somewhere, and now this is the move. So in the end, you just do the same thing, but with a few in-between moves first. And then suddenly it's no longer a tactic. That's just pretty strange. Could call this a tactic though, defense tactic. The only move that keeps the draw. Try to find that. Interesting that this is still a rule. It's because of this pawn. So the computer saw that this is a draw. It is ridiculous. How on earth can you know that in advance? Like 50 moves in advance and then in under a second. Okay. Let's make dinner. Nick, yeah, it is. I don't know, it looks like a GUI project. I have a lot of drawing and feedback in it. You know, like that.